Hello, everyone. Welcome back. We will start the next session with Elia Palme from the Swiss National Supercomputing Center. Who's going to talk to us about FirecREST, an interface for HPC and AI workflows. Thank you very much.
Thank you. Hi, everybody. Maybe before I start, to get a sense of the audience, by rise of hands, who consider themselves being a user of HPC facility or a data centers? All right. And who is on the other side, like administrator or owner? All right, great. I think it's an awesome mix. So I'm Elia, I'm a software engineer at the Swiss National Supercomputing Center. And today I'm going to introduce you FirecREST. It's a key enabler for federation at CSCS. And in a nutshell, it's an open source web API to access HPC resources or any data center related resources. It offers a standardized or common API to access those resources, and it abstracts the underlying technology, right? So we do abstract schedulers, file system, and storage, and it's based on the RESTful design principle. So we take advantage of the HTTP verbs like get, put, post, delete, and we apply them to traditional HPC. So you can post a job, delete a job, same for files, or you can get a list of jobs user is running. So it's very intuitive. It leverages standard web like OAuth 2 for authentication, REST, as I mentioned, OpenAPI to kind of disclose what the API specifications are. And of course, it's accessible over HTTP and HTTPS. Right? So you can imagine this being a kind of proxy that provides access from the web through your HPC or data center resources. It's modular and lightweight. So when we are now at the second version of the software, and a key requirement that we added was to be lightweight. We wanted the software to be easy to install and to have a very low overhead into the infrastructure. So on the kind of HPC side, we decided to make it stateless so that it doesn't require any database or data persistent to run it. And more on the user side, we wanted to integrate high performance so that you can also use it for high throughput regime, for example. That is not very typical with HPC. A second point is that the software is modular. So as I mentioned before, we do abstract the underlying technology, and we needed a way to support as many technology as possible. So you can add plugins to support different identity provider, different scheduler, storage system, etc. And lastly, we wanted FirecREST to add a layer of security with authentication and authorization. So we make sure the user credentials are legit, but we also make sure the user has access to the resources they are requesting. And in a federated model, that's very important because maybe a user has only access to a subset of the resources, not the entirety of what the system provides. All right, so next I wanted to show you some examples to kind of maybe help you understand what are the capabilities of this API. The first one is the HPC and AI integration, workflow integration. So here, one example is Airflow. We created a plugin for Airflow so that it can actually launch job into our CSCS, our HPC infrastructure through FirecREST. And so FirecREST acts as a proxy, takes care of the security, takes care of like orchestrating and starting the job inside our cluster. And it's very portable. So you can now have different instances of Airflow even installed outside of our infrastructure that through FirecREST can connect and use the resources that we provide. Another example is interactive computing. And here, traditionally, if you think, for example, about Jupyter Hub or the Jupyter notebooks, you would have to install it on a login node, and that per se kind of couples together your infrastructure with Jupyter Hub. That's something we wanted to avoid. And so through FirecREST, we can actually decouple the two. We can build an interface that the user has access to spawn a Jupyter instance on a compute node using FirecREST. So FirecREST, again, is this channel that allows us to spawn the instance just for the time the user requires it, and then free the resources. And it will also take care of like providing the user with the link to access the notebook. Similar is the integration we did with Open on Demand. Open on Demand as well requires to be installed within the infrastructure. And here we were able to kind of move it outside of it, leverage FirecREST to kind of interact with the HPC system. And an additional benefit of this is that you can have your Open on Demand installation connecting to multiple clusters, not just the one it is traditionally installed in. Custom user interfaces. This is also something that we had many requests, and I pause here because the fact that FirecREST is based on web standard makes it very easy to actually build a user interface on top of it, because it's kind of the same family of software. Most of the web UI framework do support OAuth authentication and those type of standards. And the concrete example here are either UI to monitor your pipeline, to monitor your job, so you can get the output of a job in a nice looking web interface. You can start and stop jobs. You can also access the file system of the cluster. Or another example, this is more like specific to a concrete application, is around launching simulation and then see the output of those simulation. Again, we see FirecREST as an enabler to build this kind of user interfaces in a very simple manner. Pipelines, that's also something that we connected with FirecREST. So we use pipelines at the center to automate the deployment of scientific software. And we needed a mean in order to compile the software on our bare metal, but also then to deploy it in our repository. And this is, again, operated through FirecREST. It offers a channel to actually compile the software inside our infrastructure, and then also to access the repository to upload the binaries. And lastly, we have been using it for regression testing. So daily or weekly, we run tests on our infrastructure to make sure the performance is what users expect, to make sure that maybe new libraries or new drivers are still compatible with the software stack. An example could be PyTorch and the CUDA drivers. And here, through FirecREST, we can leverage the GitLab or GitHub pipelines and run our tests directly into the infrastructure and then collect the results. So again, it's a bridge, it's a proxy into our infrastructure. So by now, I think it should be clear that FirecREST enables federation. And the way it does it is, again, by abstracting the underlying technology. We see that we offer a common API to our user that makes it transparent to the user of like what type of software, what kind of infrastructure is running underneath. So we have modules that make FirecREST run on top of Hyperq, OpenPPS, Slurm, actually even different version of Slurm. I don't know if you're aware, but from one version to another, some commands might need different parameters or their REST API changes. And so we actually kind of shield the user from that complexity by abstracting the underlying technology. The same is true for the file system and storage. Like we implement clients for S3, for example. So user can move a big amount of data first on the kind of web-facing S3 storage. And then FirecREST takes care of moving that data on the file system within our cluster. Another benefit is that because this API is de facto standardized, the different FirecREST instances can talk to each other. And so you can move now data from one cluster to another without too many complexity. Concretely, we have taken advantage of this at CSCS on our latest machine, ALPS. ALPS has actually been kind of partitioned into different clusters. We offer a set of clusters for the traditional HPC. That's the HPC platform. Then we have a ML platform, a climate and weather platform, and one platform is dedicated to the Swiss weather forecast. The software that runs on those clusters might differ. So the Slurm version might be different. Even the hardware is different. In some cases, you have access to GPUs. In other cases, you have access to CPUs. And so FirecREST here is actually used, again, to provide a unique access point to our user that is equal no matter what cluster you are connecting to. And so it allows for portability across clusters and de facto federation access. So to conclude, FirecREST abstracts HPC technologies. That's, I think, the core value of what it provides. It's a proxy enabling web access to traditional HPC infrastructures. And it's well suited to support AI and HPC workflows and integrating them with your HPC or data centers. Very important, it's built on a very modern standards and widely adopted. It's modular and very easy to be extended. Here are a bunch of links if you want to try it out. The second link is probably the most important. We have a demonstrator or a demo mode that allows you to run FirecREST on your local machine. You can provide your personal credential and it will connect to your cluster. And so you basically have a super easy installation that you can try. It's just a playground. It's not meant to be used, of course, in production this way. It's a Docker image, so you can pull it and test it yourself. The project is actively being developed. We just launched early this year the version 2 of FirecREST, and we are very, very proud of it. All right. Thank you very much for your attention. If you have any questions, I'm happy to answer those.
Do you have any insight into how many users are going through the new kind of modern REST APIs to your Slurm batch queues and things compared to the old school way of SSH?
It's difficult to answer because what we see are different workflows. So FirecREST is used often through pipelines and kind of automated workflows. So we see actually a lot of interaction through FirecREST, but it's by design because they use it for those scheduled jobs or repetitive tasks versus manually launching a big simulation that then runs for a long time, and maybe you do that only once. So I would say it's still, if I would use like not the volume as a metric in terms of load, but rather like people accessing, I would say that the majority are still using SSH because that's how they're used. But we see that when it comes to integration with workflows engine or so on, they indirectly use it without even knowing, right? So I don't know, it's probably more 20-80%, but it's a rough guess.
Thank you. So I think your technology choices are very good. But I think what your slides do somewhat is hide the additional complexity of creating a federated research environment across distributed nodes. So at least the federation you showed there was purely within ETH. So all the Alps, the bits that make up Alps. Now, if you wanted to federate into, for say, Jupiter, that involves a whole lot more legal discussion and more authorization. Have you actually looked into doing that, or looked into linking into the Phoenix RI? If you know the Phoenix RI.
No, I'm not.
I'll come and see me afterwards.
So we have a cross-site federation, but it's still within, I would say, the Swiss federal environment. So I don't know if that counts for it, but it's another university that will be EPFL compared to ETH that owns CSCS. We are in talks with CSC and bringing it to Lumi with BSC. So the idea is actually to get broad adoption across site, across country. But again, my background is more like on the software development side, so I'm more taking care of like the technical complexity, not so much the legal one, and I don't have an answer to that.
So maybe I can add, I used to be at CSCS, and maybe I have bias or unfair advantage on this thing. So yeah, so the context of federation here is not like the identity federation or services federation in the sense of across entities. I think the way to look at these interfaces are, these are the interfaces to POSIX within a single entity ecosystem, because POSIX doesn't have all the interfaces we just take for granted in modern web environment or web-friendly environment. So what Elia showed is within an organization, and this is by design, because what you do not want to do is run it across organization, because otherwise you will start creating very much, I mean, to me, this idea in AirFed, now you say Sadaf is kind of, he has a split brain situation. So there, the idea was you wanted to do an identity federation and a federation of resources and proxying. This is a technology federation inside an entity. And if you start doing it across entities using FirecREST single instance, you will break this service or site service provider autonomy in that way. So personally, I would never do that, but that's like sort of personal choice to use this tool across legal entities. Yeah, so, but this is a way to federate inside the modern standard or authentication and authorization system.
So for instance,
Technologies
between Isambard AI.
that are POSIX based.
Yeah,
That's what I call it.
But you could federate between, for instance, Isambard AI and Isambard 3 internally using this.
I might not.
You could do it.
Yeah.
That's
I could.
the use case it's designed for.
Yeah, but what it allows me is, as Elia was highlighting, that if I'm working, let's say for a platform provider, and I don't want to pick like a favorite or something to pick up on, but let's just take something less controversial, like open on demand or some kind of, I don't like this thing, but sometimes users create remote desktop or these type of environment, and they currently have to lock in the tool with the HPC system, with their login nodes, with the service. What it allows you to run it outside that framework. So you do not have to bind in and tightly couple technologies such as your front-end nodes and service nodes of an HPC system. It runs on a different layer where you can reuse or recycle technologies. So yeah, it allows, so for some of our use cases were people building platforms such as Materials Cloud, and they have a whole suite of applications. And part of the Materials Cloud was to talk to HPC system and to talk to some storage entities. And there, what they did was, and they say, but we also want to run on, so Phoenix is this HPC Center Consortium. I was every other thing. But then they said, yeah, we will only use the thin identity layer for federation, but I would like to deploy something different, for instance, at Cheneca. But then them as a platform designer, they can make those calls. They do not have to rely on me, or they say, these give me just the API endpoints and I can build my application in a consistent way. And tomorrow, if I retire one machine or if I change architecture of other, I do not have to go again and figure out what are the like DNSs and what are the kind of all these other. So it really decouples your platform design. It goes to the idea that Paul also mentioned. It really decouples the infrastructure provisioning from platform provisioning. And you need these types of tools. So I'm not saying this is sufficient. It is essential. But yeah. So it is, maybe federation in this case was used in a way which gives an idea you can do it across. You might, I wouldn't do that.
So earlier I asked, do you have any kind of insight into the split between users who use SSH versus the APIs? So to rephrase that then, or switch it up a bit, do you see the split of the workloads, the portion of workloads running through, the REST APIs and your workflows compared to people who are just logging in directly? Because from the Hartree Centre perspective, this is, pushing an open door to me. I think this is the future for us as well. But I'm just trying to kind of build evidence that this is something that we want to do at the Hartree Centre. So any kind of evidence to suggest, there's lots of, we've seen an uptake in usage through, pre-built workflows, pre-canned workflows and customization of workflows, then that would be great to hear.
I would say it depends on the community, like probably communities that are traditionally being already accustomed to HPC tend to stick to what they, tool they use. In the ML side or AI kind of community, that's we see an uptick and an advent kind of, it's easier to propose newer technology or kind of a different approaches and compared to user that have been traditionally using SSH, for example.
One other way to ask is, with established technologies or an established site versus, so Elia showed like multiple tenants on Alps. I think one way to ask this question is, what is the fraction of uptake on AI platform versus HPC platform? And the distribution will look different because one community is more friendly or more open, or their workflows are more web or cloud oriented, or just going from a direct laptop, versus a community that is very, I mean, they have set ways in doing things, and you don't change it unless you absolutely need to. So yeah, I think it would vary. Yes, you don't change things just for the sake of changing things. So FirecREST was also used for providing, I think, SSH certificates for logging in. So once you have this setup, you could use this environment to tighten your security, to do more control thing. So, I mean, but we are going kind of sidetrack. So yeah, if you don't need to, you probably don't have to kind of thing. But if in heart you really want to put everyone behind this type of data center API, and this is your operating model.
Not everyone.
Yeah.
We've got a hardcore SSH contingent, like everyone else.
Yeah.
But I see the value, especially for AI, so for AI workloads. Yeah, you see more of an uptake in that.
Yeah. So I think that would be what I would say.